Okay, so before we jump into today's material, you guys have any questions for me? Anything you want to talk about before we begin? Okay, so today we're going to learn a new set of methods. So we've learned our first real tools for making inference. We're looking at just a sample of data and using it to understand an entire population. Right? So we looked at these two methods, claims about a population mean, and then we also looked at that claim about a population proportion. So these are powerful tools. You know, again, people in power are going to make claims to you your entire life, and sometimes they're going to be based on data. So now you have these tools at your disposal. You can now go out and collect your own data. And you can test those claims, those hypotheses, and really see if whatever they're saying is how the real world works. Today we expand this. We take this idea, we modify it in a slightly different way. So this time around, we're not looking at, say, a person in power, but instead we're thinking more about, you could say, a doubting scientist. So I'm giving you guys like a new person to base your null hypotheses off of. So today we're going to talk about comparing groups, comparing populations. These are really the tools that people use when they talk about really any kind of scientific activity. So you think about the vaccines that are coming out. So they do these clinical trials. So they get two groups of people, half get the vaccine, half don't. And they follow up on them, a few months later, and they count how many of them got COVID and how many didn't. So the same technique, the same tool works in social science too. So if you're going to work for a police agency and you start a new program, a new form of policing, maybe to improve your response times to calls for service, the same thing applies. You have your old practice or your standard practice, and you have this new practice. So you want to compare the two. You want to see if the new practice is better than the standard practice. Zach, would you mind closing the door for us? Appreciate it. So, when I think about your own research, or the research that you're doing in this class, there might be some questions that you've been longing to know the answers to. When it comes to some of your results, and the work that you've been doing, I can see that it's really tempting to want to think like this. So finally, we get to think like this. So I know if you're doing, say, the alcohol use survey, you might be really interested in knowing, well, if your parents drink, does that increase the likelihood that you're going to drink? Or if your parents drink, do you drink more? Or if we're talking about fear of crime, we might have some questions like, is there a gender difference? Are people who identify as female more fearful than people who identify as non-female? Or maybe you're interested in things like prior victimization. If you've experienced crime, you've been the victim of crime in the past, are you more likely to be fearful of crime than somebody who hasn't? So these kinds of questions, this idea of taking two groups and comparing them about something, that's what we're going to talk about today. So powerful tools. You can think about it in terms of just your own research, your own questions about how life works. But you can also look at things from more of an experimental standpoint. So at some point in your life, you might come up with a new program, a new social policy, and you want to see if we implement this, does it actually make things better? Or are things still just the same but different? Now, when it comes to this methodology, again, It differs. So last time we talked about the person in power. We use that as kind of our heuristic, our tool. We're trying to figure out what the null hypothesis is. So this time around, instead of thinking about a person in power, I want you to think about the doubting scientist. So I don't know if you've heard this like cliche, but the skeptical scientist. Have you guys heard this before? No? Okay, well, okay, if you think about like stereotypes about people in the world, who are considered like really skeptical people? Is there like a type of person? You don't have to be like
Definitely scientists.
the scientists.
Anybody.
So why is that?
I was just thinking, like, in the context of like religion or any type of, non-scientific mode of thinking, scientists are generally skeptical.
Okay, so maybe this is where that idea of a doubting scientist kind of comes from. It's like, all right, some people, we have ideas about how the world works, alternative, explanations of how things are, and then you might have that idea of the scientist being like, okay, well, show me the proof. Where's the data? So, you can use the doubting scientist as your model. You can also think about, they've been really working hard to release the vaccines as fast as they could. But before they do this, they still have to do these big clinical trials. Like thousands of people had to get tested to see if this vaccine works before it would even be released to anyone. You can think of that as being like kind of doubting, right? Like somebody in a lab took the virus, they put the vaccine in it, and they're like, oh, the virus went away. But like the FDA is like, no, that's not good enough. You actually have to give it to people, and they have to not report symptoms or and things like that. So maybe the FDA is like really the doubting organization in this example. Anyway, just think doubting scientist. It's the person that always says things are never going to change. There's no difference between these two groups. Everybody is the same. Now, in order to use this method, we're going to have to use a new flow chart. So we actually have two new flow charts. So we'll talk about comparing means between two groups. So if you want to talk about continuous things, like fear of crime, number of drinks, number of housing problems, you want to compare groups. This is the flow chart you use. But we're also going to talk about proportions. So sometimes in life, we want to compare the proportion of people in one group, the proportion of people in another group. So if you're in fear of crime, you might be interested in, say, prior victimization. So the proportion of people who've been the victim of crime in the past. You might look at, say, just the women in your sample and say, okay, the proportion of women who've been the victim of crime in the past, is that different than if we just look at the men, the proportion of men who've been the victim of crime in the past? So you might have questions like that. So to answer those questions, you're going to use this flow chart. Okay, so here's the deal. We need statistics. So we can't just make comparisons by just looking at the data. Because here's the deal. Sometimes you can look at your data and your results are going to be very clear. Anyone could just look at them and go, of course, these groups look different. So, like imagine we have two samples, A and B. Imagine this is like, maybe this is the population of all the women here at Southeastern. And maybe this is the population of all the men at Southeastern. And maybe we're interested in a proportion. So here we have red and yellow dots. Here we have red and yellow dots. We can see that maybe those dots are things like prior victimization. The yellow dots mean you've been the victim of crime in the past. Red dots mean you haven't. If we look at these two samples, these are the women, these are the men. Who has the more yellow dots? B, right? So if we look at this example, clearly we conclude And when it comes to prior victimization, that those who identified as men were more likely to have been the victims of crime in the past than those who identified as women. Maybe logically this makes sense, right? Like, guys like to get into fights, they don't always think things through, they just they get offended, so then they turn to some kind of physical violence, I don't know, stuff like this. So sometimes when you look at your data, it can be really clear. Other times you're going to look at your data and it's going to look like this. And it's not going to be easily seen whether or not these two groups are different at all. Or they may differ by just a small amount. And then the question is, well, is that difference, is that a real difference? Or did you just get some bad samples? Is it just noise? Just random chance? So we need the statistics to help us tell the difference between whether or not two samples from two populations are actually different. A lot of times, in social science, we come up with these new programs, they're effective, but they're not like night and day effective. It's not like you're taking a family in a poor neighborhood and you're taking them into a rich neighborhood and you just pay for everything for the rest of their life. We're not going to see differences of that magnitude, but we will see that they help to some extent. But sometimes we need statistics to help us actually know if those differences are real or again just random chance. Are you guys with me on this? So we want to compare groups. We want to compare men versus women, fear of crime. We want to compare, people who've been raised by parents who drink versus those who don't drink, and how that might affect how much alcohol they consume. But sometimes, looking at two groups and saying they're different, sometimes it's easy. Sometimes we're going to really need statistics to let us know if those differences actually exist. Okay, so we have two methods for doing this. So we have our first method, which is this claim about two population means method. So really in this lecture, we have two methods, comparing two groups, two population means, and then later on in the lecture, we're going to have two groups, two population proportions. So if you're going to use this method, there are several assumptions. So one of the assumptions we have to pay attention to are the types of data we're using. So again, we learn these methods, but we can't just use these methods on any column of data in our database. So we can only use them for certain kinds of data. So we can only use this method whenever we have one variable that splits our sample into two groups. It's going to be our independent variable. So it could be male versus not male. It could be freshman versus not freshman. It could be rural versus non-rural. And we're going to need some other variable that we care about. Something continuous. Something like number of drinks consumed. Something like safety feeling. So that safety feeling score. Or that fear of crime score. Or number of housing problems. So if we have data like this, then we need to check our assumptions, and we're going to have three assumptions. And we've seen these assumptions before. They're a little different though. So we are assuming that one, there are two possible populations. So could be females are different from non-females. We're also assuming that we're talking about population means. If you're ever interested in a proportion of people, so the proportion in one group versus the proportion in another, you can't use this method. We use this method when you talk about fear of crime, safety feeling, number of housing problems, satisfaction with where you live, how many drinks you consume, how many drinks you think the typical Southeastern student consumes, how many drinks people's fathers consume or mothers consume. This is the method to use. And then we have this independence assumption. So we have this assumption that when we surveyed people And what they told us was their experiences and what they thought, and that the answers they gave were not going to be influenced by anyone else who took the survey. Okay, so we have this method, and we're interested in comparing two groups. We're interested in comparing the sample mean of group 1 to the sample mean of group 2. And we want to know if those sample means are different. To do that, we use a test of hypotheses. So here we have our 6 steps. So these are the exact same 6 steps that we've been covering this whole time. So step 1, we need to state our null, our alternative hypotheses. Step 2, we need to state our significance level. Step 3, we need to determine the appropriate statistical method and check the assumptions. Step 4, we determine the p-value. Step 5, we compare the p-value to the significance level. We either reject the null or not. And then step 6, we interpret our results. So if we reject the null and we accept the alternative, what does it mean to do that? Or if we fail to reject the null, we say the null is possible, and to explain what it means to do that. So let's consider an example. So I do a lot of work with the juvenile court. I'm interested in things like recidivism. I want to know why some youth take longer to reoffend compared to others. So I might be interested in, comparing 2 years. So with the juvenile court that I study, there was this big legislation that happened. They just effectively provided more funding to juvenile probation. And this was going to allow for more programming, greater supervision, things like this. So my question was, okay, well, if all this stuff started in 2013, did it have any effect? Were the youth in 2013 any different than the youth in 2012? So here I'm interested in recidivism. I want larger recidivism values. So I know it's kind of strange to think, but you want large values because that tells you that it's taking you longer to return to the court after committing some offense. So I have my dependent variable, which is recidivism, number of days until new offense. I have my independent variable. So here it's dichotomous. It's got 2 categories, 2012, 2013. And then I've got 2 samples of data, and I've crunched some statistics. So we get a sample mean for 2012, sample mean for 2013. We have a standard deviation for 2012, and a standard deviation for 2013. But here's the deal. Just looking at the sample statistics, it's hard to know for certain whether or not the recidivism rate, the average recidivism for 2013 is different from 2012. So if we look at 2013, we see it's 377. And if we look at the average for 2012, we see 262. So if we're just talking about averages, it looks like it's taking youth longer to recidivate in 2013 than in 2012. So we get the idea that, maybe all this legislation, maybe it worked. However, when we look at these standard deviations, you can see that there's a big difference between the 2. So here the standard deviation is 238. 2013, it's 350. So remember, think of it like this. The mean is the average. The standard deviation tells us about how far away from the average all the values are on average. So you can think of it like 2012, the recidivism rate was 262 days. And when it came to all of the youth, they were spread around from that by 238 days. So think of it like this. In 2012, the values around the mean were a lot closer than in 2013. It's a larger value given. So it can be difficult to tell. 2012, the youth were kind of more the same than in 2013. So is this difference, again, is it a real difference? Or is it, do we just get lucky? Do we just happen to like sample the right youth to get this number?
What's an example of like a null hypothesis for this particular scenario?
Okay, so good question. So the null hypothesis is the doubting scientist hypothesis. There is no difference between the population mean in 2012 and the population mean in 2013.
The alternative that will be there is a difference.
Yeah, some kind of difference.
Some kind of difference.
So you got to think of again this doubting scientist claim. The policy didn't work. The paying probation officers more money, giving them access to more programs had no effect. That's the doubting scientist claim. So we can test that claim. Is that difference real? So we go to step one. We specify our null and our alternative hypotheses. The null is always that doubting scientist claim. Nothing works. Everyone's the same. So the null here is that the population mean recidivism in 2012 is the same as the population mean recidivism in 2013. And as Cody pointed out, the alternative is that there's going to be some kind of difference. So here I'm just doing a two-tailed difference. I'm saying that average recidivism in 2012 differs from the average recidivism in 2013 in some way. Maybe it went up, maybe it went down. I'm not being specific about it. And again, when you're doing this, whenever you're comparing two populations, you're going to have one null hypothesis to choose from. It's always that doubting scientist hypothesis. It's always that the population average for population 1 is always the same as the population average for population 2. However, when it comes to those alternative hypotheses, there are going to be 3 that we can choose from. So we have the idea that either the two populations are different, or population 1, their mean is greater than the population 2 mean. Or population 1 mean is going to be less than population 2 mean. So we refer to these as a two-tailed, upper-tailed, and lower-tailed test. What questions do you have for me?
Is one result into the proposed?
So in this case, there is no proposed. That's a good question. So in this situation, it's the population 1 mean is different from the population 2 mean. So it's almost kind of like there's no value. So nobody's going to say the population difference is, like 20 days. Instead, it's just how the different populations relate to each other. Are they different? Is one bigger than the other? Is one smaller than the other? So here, when we're writing these hypotheses, you're not going to include specific numbers. You're just going to be talking about population means for one group and how they compare to the population mean for the other group.
How do you, so like for, dichotomous variable, such as like white and non-white, how would you definitively choose which one is population 1, which one is population 2, for the purpose of like choosing an upper or lower tail test?
Very good question. So it's your choice. The trick though is you have to be consistent. So if you want to make population 1 white and then population 2 non-white, or you want to make non-white population 1 and white population 2, it's completely arbitrary. You can pick whichever one you want. However, you have to be consistent. So if you're not consistent with the rest of this process, with those designations, then it's going to throw off the results. And you might come up with conclusions that aren't actually what's going on within the data. So I'll show you how to do that, how to keep things consistent. So warning, we have to be consistent. So as like logical people, You know, there are a lot of ways to say the same thing, right? We know that. However, when it comes to SPSS, SPSS doesn't think like us. It's not logical. So like, here's an example. So you might have a null hypothesis, and that's that the population mean for population 1 equals the mean for population 2. The groups are the same. There's no difference. Now, another way you can write that exact same statement is shown here at the bottom. The mean for population 2 is equal to the mean for population 1. So look at these two null hypotheses. You guys see how they're the same? How they're basically saying the same thing? So if you read the first one from left to right, and then you read the second one from right to left, it's the same statement. You guys see that? Mean population 1 equals mean population 2, left to right. If I go right to left, mean population 1 equals mean population 2. I said the same thing. So logically, you know, we can make claims about how two groups are the same in different ways, and we know what we're doing. You know, we're looking at the two groups and we're claiming they're the same. There's no difference. But SPSS won't know that. So if you pick one of these, you have to be consistent about it. You have to be consistent with how you enter the data and use the routines in SPSS, because it's not going to know automatically which is population 1 and which one is population 2 unless you tell it which one is which. So SPSS, when you use the statistical routine, it's going to give you a box. You need to specify what population 1 is. So here they call it group 1. And you need to specify what population 2 is, or group 2. And this is going to depend on the order of your null hypothesis. So if you have a null hypothesis that looks like this, the population mean in 2012 equals the population mean in 2013, then this population going to the left of the equal sign, that's going to be population 1, group 1. Here we have the group to the right of the equal sign, 2013. So that's going to be population 2, group 2. So it goes down here. So you need to make sure your hypotheses are consistent with this order. You need to make sure that SPSS is consistent with that order. Otherwise, SPSS is going to give you conclusions and results that are going to be backwards and wrong. Questions? Okay, so step 2, we set our significance level. Remember, in life, we make decisions, and it doesn't matter what decision you make, there's always going to be a chance that you're wrong. Now, where statistics is a little different, is that we can control that chance of the mistake we're going to make. So we can say explicitly that we think being wrong 1 in 20 times is fine. That's where that 5% comes from. Take 1 divided by 20, you get 0.05. So we set this value, we say, we got a null hypothesis, we have this doubting scientist claim, here's this Yahoo who's saying that there's no difference between the two groups. We're going to make a decision about that claim. We're either going to agree with it or disagree with it. And again, there's a chance we're going to be wrong. But we can specify that chance and set that threshold. So standard in science is use 0.05. We're saying we're going to make a decision. There's a chance that we're wrong, but we're going to say that we can live with being wrong 5% of the time. But that's reasonable. Step 3, we then determine the appropriate statistical method. So in this case, we're using the difference between two population means method. We have our 3 assumptions. So we need to state the assumption, and then we need to justify it. And when it comes to these assumptions, they're typically based off of an argument. So we're assuming two populations. This is okay because we're comparing two possibly different populations. Two, we're assuming population means. Again, this is okay because we're making claims, testing claims about two population means. And three, we have our independence assumption. Now again, this one is based off of how you collected the data. So, you want to make sure that when you collect your data, that the way one person responds is what they think, and that it wasn't influenced by anyone else who took your survey. So again, if you're like, target people individually, maybe by sending them out over email, it's a reasonable assumption to make. That when they took your survey, they were taking it on their own, and they weren't around anyone else who took the survey. If you were doing like surveys, like old-fashioned style, paper pencil, you go up to like a table of students, there's like 10 people there, and you just plop them on the table, and you say, all right, guys, fill them out. You're bound to have some people, look at each other's responses and say, oh, what did you put down for question 5? Have you been the victim of crime? Did your parents drink alcohol growing up? Of course they'd be curious. And the trouble with that is it could affect the results, right? People might get self-conscious. They might think, okay, I gotta change my numbers just in case any of my buddies want to know what I put down. Step 4, we go to SPSS. You have your data. You're going to go to Moodle. You'll go to the Fieldwork tab. You'll go to the data set. That's the newest of the cleaned data sets. So that's the one you want to use. And you'll pick 2 variables. So in this case, I'm interested in 2 years. So 2012 versus 2013. So I've got some column that just indicates whether or not the youth that I'm focusing on, whether they recidivated in 2012, or whether they were a recidivating youth in 2013. And then I have another variable that I care about, recidivism, so the number of days it took each youth to reoffend. So I take this data, put it into SPSS, I get results that look like this. And when it comes to these results, when it comes to reading this table, you're going to use the second row. So ignore the first row.
So you said ignore the first row, use the second row.
Right. So on Thursday, we're going to talk about some design ideas. So I'll kind of explain then why you prefer one row over the other, your safe bet, and what you'll see on the exam and all that. Second row. From this table, you'll look at the second row, you'll pick the number under the key column, and you'll pick the number under the SIG two-tailed column. So SPSS is going to do some work for us. It's going to give us some numbers, some statistics, but we still have to do a little work on our own. So we want to get that p-value, so we can make a decision about that null hypothesis. And SPSS is going to get us some of the way there, but sometimes it's wrong. We can't trust SPSS all the time. We need to go to our flowchart. When we go to our flowchart, we need 3 things to find the correct p-value. 1, we need to know what our alternative hypothesis is. 2, we need that t statistic. And 3, we need that SIG two-tailed value provided by SPSS. So we go to the flowchart and look at our alternative hypothesis. So here it's that recidivism is different between 2012 and 2013. So here I'm doing that two-tailed test. So that tells me which of these 3 groups in the flowchart that I go to first. So here I'm doing the two-tailed test. Because an alternative hypothesis has this form. The average of group 1 is not equal to the average of group 2. Now, if I'm doing a two-tailed test, and the results provided by SPSS are always going to be correct. So I'm doing a two-tailed test. So that tells me that the SIG two-tailed value That's my p-value. So I have a p-value. Remember, we use this idea of a p-value, and I'm giving you the definition that you can think of the p-value as the probability of incorrectly rejecting the null. So if the p-value is really big, and you decide to reject the null, there's a good chance that you've made a mistake. However, if the p-value is really small, and you decide to reject the null, then there's very little chance that you've made a mistake. So this definition isn't really like the correct way of explaining what the p-value really is, but I think it gives us like a good intuitive foundation to know what the statistic is telling us. So we have our p-value. Once we have our p-value, we're going to decide whether or not the null hypothesis, whether we're going to reject it or fail to reject it. So we take our p-value, compare it to our significance level, 0.05. So in this situation, we see that the p-value, which is equal to 0.224, is greater than 0.05. So what do we do in this situation? The other one, right? So we're going to fail to reject the null hypothesis. What does it mean to fail to reject the null hypothesis? Sure, yeah, I think a better way to interpret it is to say that the null hypothesis is possible. We can't rule it out. So we have a p-value, it's big, we're going to fail to reject the null hypothesis. And then we interpret that statement. We have failed to reject the null hypothesis. What does that mean? Like in real words. These are like sort of real words. So you can say that at the alpha equals 0.05 level, we have insufficient evidence to conclude that there is a statistically significant difference in recidivism between 2012 and 2013. Right, so it's possible that that doubting scientist was correct. The person who said, oh, there's no difference. This policy is not going to change anything. We can't rule it out. We don't have enough evidence to say that they're wrong. So when it comes to your own comparisons, I want you to have your definition be as close to this as possible. But just change the words in the gray box and match your context. So you'll match it to, fear of crime, or alcohol use, or housing insecurity. Questions? So sometimes in life, we're interested in comparing continuous things, like who pays more money in rent? People who live in urban areas, or people who live in, like rural areas. Sometimes we're interested in comparing fear of crime between genders, or we're interested in the number of housing problems people have. Again, maybe by rural versus urban. Or we're interested in things like alcohol consumption. So, if you were raised in a household where your parents drank, do you drink more on average than those, who are in households whose parents did not drink? So sometimes we care about those kinds of questions. But other times we care about questions about proportions. So you might be, say, doing the fear of crime survey. Who here is doing the fear of crime survey? Okay, so a couple people. So you might be interested in things like, well, does gender have an effect on whether or not you have experienced any crime victimization? So you might be interested in things like, if we're looking at those who identify as female, like just that group, and we ask each one, have you been the victim of crime before? We can create a proportion. Maybe it's like, I'm just making up numbers. Maybe it's like 30% of all the people who identify as female say, yes, I've been the victim of crime before in the past. And we might be curious about how that proportion compares to those who identify as non-female. So you go to just all the people who identified as male. You might look at them and say, okay, have any of you been the victim of crime in the past? Calculate another proportion. maybe it's like 40%, 50%. So we want to compare these groups. We want to compare proportions between these two groups. You know, if I think about recidivism, a lot of times I'm interested in comparing two groups. I might be interested in how girls recidivate compared to how boys recidivate. I might be interested in whether some new, fancy, flashy program affects recidivism compared to traditional juvenile court practices. So sometimes I think about recidivism in terms of the number of days. It's like a continuous thing. But other times I think about it in terms of a proportion. Just in general, the proportion of youth who recidivated in, say, like 3 years versus the proportion that didn't. Is there a difference in that proportion? But depending on, you know, if someone got that new fancy program or if they just got supervision as normal. But sometimes we care about proportions. So we have this second method, the difference between two population proportions. And some of the ideas that we're going to talk about here are similar to the ideas we just talked about, but there are going to be some differences. One of the big differences has to do with the assumptions. So, you know, we have those 3 assumptions that we talked about. Those have to be met. We're going to use the previous method. Here we have 3, we actually have 4 assumptions. And that 4th one is going to be kind of a doozy. Also, another big difference is that if you want to use this method, you can't do this in SPSS. So SPSS does not have a routine for doing this kind of statistical analysis. So we're going to use we're going to use a website that has some online tools that you can use to do this kind of test. So we have this difference between two population proportions method. It has 4 assumptions. It also has some stipulations about the kind of variables you can use this method on. Remember, you collect all kinds of data. You can't use any method you want on any kind of data. So you use this method when you have 2 variables that you care about. One that divides your sample into 1 of 2 groups. So it could be females versus not females. And 2, when you're interested in some other variable that divides your sample into 2 groups. So it could be prior victimization. Yes, no. And then we have 4 assumptions. We have the assumption of 2 populations. We have the assumption of population proportions. We have the assumption of independence. So again, everyone who took your survey, they provided you with their answers. They weren't being influenced by anyone else's answers. And then we have this large samples assumption. So when it comes to this large samples assumption, you have to check it. This is not an argument. You have to look at your data. So push up your sleeves, crunch a few numbers. If those numbers show you that your data have a large enough sample, then you can continue to use this method. If any one of those things that you check are violated, then you can't use this method. So to do this, use this method, we have our 6 steps, same 6 steps that we've talked about. So null and alternative hypothesis, set the significance level, determine the appropriate statistical method, check the assumptions, determine the p-value, compare your p-value, your significance level, and then make a decision and interpret your decision. So let's consider a different example. So we might consider something from the prison climate survey. So I went to correctional facilities across the state of Kansas, and I surveyed inmates and staff members. And I asked them this question: do you think that there are really threatening inmates in this facility? So they were able to respond with either a yes or a no. So I have one sample, my staff members, and they all answer this question, yes or no. And then I have all the inmates that I talked to. And they looked at this question. They answered yes or no. So we might want to compare the proportion of staff to the proportion of inmates. See if there's some kind of difference there. So if I look at the proportion among the staff, it equals 0.59. If I look at the proportion among the inmates, it's equal to 0.5. So we look at these two proportions. You guys think they're different? Yes? No? So they could be different. They could be different because they really are different. Or they could be different because we got lucky. You know, we went out and we took a sample, random sample of inmates, random sample of staff members by pure chance. Just happened to turn out this way. So we need the statistics. We need to use this method, this website that we're going to talk about, to statistically decide whether or not these two proportions are in fact different from each other. So step one, we state our null and our alternative hypotheses. So again, our null hypothesis, so it's always that doubting scientist hypothesis. The proportions are the same. There's no difference between these two groups. So here we have proportion of staff equals proportion of inmates. Now, based off of my own experience, working with staff members and inmates, I might have a hypothesis of what I think is happening. So I might think, actually, I think when it comes to these proportions, the staff members think that more threatening situations can occur here more than the inmates. So we state our null, we state our alternative hypothesis. And again, whenever we're using this method, there's only one null hypothesis. The proportion population 1 equals the proportion in population 2. Now, when it comes to your alternative hypothesis, again, there are three alternatives. The proportions are either different, the first proportion is greater than the second proportion, or the first proportion is less than the second proportion. So here's the website we're going to use. It's kind of old-fashioned looking, but you know, it's probably not any more or less old-fashioned looking than SPSS. So here's the website, and here's a link down to it, down at the bottom. So you can just click on it, and it'll open up in a browser. The homepage looks like this. It has a whole bunch of statistical tools that you can use. So, you know, who knows, maybe in the future you won't have access to SPSS. You might decide to go to this website and use these tools. So this website has the same caveat as SPSS. You're going to make a claim, you're going to state your null and your alternative hypotheses. And the way you organize what is population 1 and what is population 2, you need to make sure that you're clear about it, and you need to make sure that you're consistent about it. And you need to be consistent not only in your hypotheses, but also with how you enter that information into this website. So if you flip them around at any point, you're going to get results that are incorrect. You have to be cautious. So that's a phrase. Never trust software. So you'll go to this website. There are going to be two fields. Here they call it sample 1. Here they call it sample 2. So if your null hypothesis is something like this, so the proportion of staff equals the proportion of inmates, you feel this way. And staff are your group 1, population 1. So all the information from your sample goes in this first field. And by looking at this null hypothesis, since the proportion of the inmates is to the right of the equal sign, that tells us that all of the sample statistics that we calculated, that goes down here in this green box. So it's the sample 2. Step 2, we set our significance level. So we are making a decision. We're going to decide to reject the null or not. So somebody, some doubting scientist, has made this claim. that the proportion of staff members who think that threatening situations can occur is the same among the inmates. If you look at just the inmates and you calculate the proportion of them who said threatening situations can occur, that the staff are equal to the inmates. So we have to make a decision. We have to decide, is that claim true or not? And we're going to use data, our data, to make that decision. So we're going to make a decision. There's always going to be a chance that we're wrong. So we need to specify our threshold. So we set alpha or significance level equal to 0.05. Step 3, we determine the appropriate statistical method. So here we're thinking about two groups. We want to compare the proportion in one group to the proportion in the other group. So this is the method we use. We use the difference between two population proportions method. And we have our assumptions. So we have to justify these assumptions. We cannot justify these assumptions. If any of them are grossly violated, then we can't use this method. If we can't use this method, we can't compare the two groups. We're not able to make a decision about that null hypothesis. So our first assumption is that there are two populations. So here it's okay. So we're comparing two possibly different populations. Our second assumption is this idea of population proportions. So think about the claims that are being made. Think about that doubting scientist claim. What are they talking about? So in this case, it's okay, because that claim is about comparing two population proportions. And 3, we have our independence assumption. Think about all the people who took your survey. Think about all of those individuals. If it's reasonable to believe that the way one person responded wasn't influenced by anyone else, this assumption is satisfied. Now the fourth assumption, this is the tricky one. You have to push up your sleeves. And you have to do the work to check if this one is valid or not. So this is this large sample assumption. So there are 4 criteria that you need to check. And if any one of these isn't satisfied, then the whole assumption isn't satisfied. So you need to check them all. So there are 4 of them. In the context of this prison climate survey, what we do is we take our information from our first sample, and we take the sample size, multiply it by the sample proportion. We're going to get a number. If that number is greater than or equal to 5, then this first criteria has been satisfied. We then take that sample size again, multiply by 1 minus 0.59 in this case. Here we get 85.69. So again, our second criteria has been satisfied. Bigger than or equal to 5. Then we go to the second sample. We check 2 criteria there. We take our sample size, multiply it by the sample proportion among the inmates. Here we get 158. This number is greater than or equal to 5. So this criteria has been satisfied. And then here we take our sample size, multiply it by 1 minus 0.5. In this case, again, we get 158, greater than or equal to 5. So all 4 of these criteria have been satisfied. So since all 4 of these have been satisfied, we know that our sample is large enough. So we can use this method. So we can test that claim. We can look at that doubting scientist claim and then decide whether or not it is, correct or incorrect. So we take our sample statistics, our sample sizes, our sample proportions, and we go to this social science statistics website, we plug them in. All the stuff for your first population goes here under sample 1. All the statistics from your second population go under sample 2. We'll then check this radio button next to significance level. Just click 0.05. and then select the radio button next to the two-tailed method. Here's the deal, guys. So you set all this up, it'll calculate, and press this button that says calculate Z. This website is gonna provide you with some output. Here it's in blue, sometimes it's in red. It's gonna try to tell you the answer to the question. You cannot trust this website. Not always gonna be right. You have to be really cautious. So you're gonna get some verbiage here. It'll sound like the answer, but it may not be the answer. You're gonna need to get some information from it. You're gonna need to use a flow chart, and then you're gonna use that information to find the real answer. So don't trust this website. So you'll get a message here in blue or red. They'll say that something called the Z value equals a number. Then they'll say that P equals some number. You want to write that down. And then you take those two values and you go to your flow chart. So we look at our alternative hypothesis. We see what kind of tailed test it's using. So here we have this claim that the proportion of staff members who think that threatening situations can occur in the facility is greater than it is among the inmates. So we have this upper tailed test. So when it comes to this flow chart, there are 3 sections. We want to go to the one for the upper tailed test. There are then 2 sub-bullets. So if Z is positive, we do one thing. If Z is negative, we do something else. So we look at our Z value. Here it's equal to 2.0241, the positive number. So if Z is positive, then your P value equals whatever this P number is that was given to you by this website, divided by 2. So here our P value is actually equal to 0.0434 divided by 2, which is equal to 0.0217. So we have our P value. Once we have our P value, we can make a decision. We can use that P value to decide whether or not that doubting scientist was correct or not. So we take our P value, compare it to our significance level. So in this case, 0.0217 is definitely less than 0.05. Since it's less than 0.05, we're going to reject the null hypothesis. So that doubting scientist was wrong. Then we interpret our results. So we say something like, at the alpha equals 0.05 level, we have sufficient evidence to conclude that staff are more likely than inmates to think really threatening situations can occur. And again, when it comes to these interpretations, try to get your interpretation as close to what I'm providing you here. You know, just change out what's in the gray boxes with the context of your own research. What questions do you have for me? Okay, so I want to just take a few minutes to just look at this website, because I know for all of us, I guess in this case, it's new. I don't really like Explorer. So I want to go here. So where did it go? I just want to take a minute to hang out on this website. I just want you guys to get familiar with it. I mean, you're going to be using it. Hopefully you have like an ad blocker and you don't have to see all this, junk. So, it's going to have some kind of description about what this method is about. The area you really want to pay attention to is, again, these boxes here. So you're going to have 2 groups. So let's say we're doing fear of crime. So you might be interested in people identified as female versus non-female. So you might look at just the females in your database. And you might be interested in some kind of proportion, maybe whether or not they've been the victim of crime in the past or not. So you can use SPSS to calculate some statistics for you. Your SPSS will tell you how many people you've talked to who identify as female. And SPSS will also tell you the proportion of those individuals who have identified as female who have been the victim of crime in the past. So if this is your first population, so if you think something like the null is that the proportion of people who've been the victim of crime in the past among those who identify as female is equal to the proportion of people who've been the victim of crime in the past who are not female. So females are going to be your population one. And all that goes into what's said here at the beginning, is sample one proportion, and then also your sample one size. So you're going to use SPSS a little bit with this website. It's going to give you some results that you can use, but again, it's not going to get you all the way there. You have to just get those numbers from SPSS and then plug them into the website. So you'll also figure out sample proportions and sample sizes for your second group. So again, if we're sticking with this fear of crime example, talking about people who identified as not female, typically in your surveys, people who identified as male. So you'll look at those individuals, you'll calculate a sample size, like how many people identified as non-female, and then you'll also calculate a sample proportion, the proportion of those non-females who have been the victim of crime in the past. And then all that information is going to go here under the sample 2 proportion and the sample 2 size. And again, things like the significance level by default is going to be 0.05. You can just leave it there. By default, it's going to ask you if you're doing a one or two-tailed hypothesis. By default, it picks two-tailed. Again, this website is going to try to guess for you, but it actually doesn't know what you're doing. It doesn't know what your null hypothesis is. It doesn't know what your alternative hypothesis is. All it knows is that you've got some data, some statistics, you've plugged them into these boxes, and you're clicking calculate. It's going to try to guess. Sometimes it's going to be wrong. Just remember, when you're using this website, don't trust it. It's going to give you an answer. Ignore its conclusion. Get the z-value, get that p-value, and then use your flowchart to actually find the real p-value. So I mean, we can, just plug in some numbers real quick. So these aren't actual, numbers from any data set. I'm just making things up. But if we said, say, prior victimization, I mean, from the research I've done, or the studies I've read, men tend to have more experience with victimization than women. Sort of what I've been seeing. So there's like weird, strange kind of hypothesis where men experience more victimization than women, but men are also less fearful of crime than women. Like kind of a paradox, right? And you'd think if you're the victim of crime that you'd be worried that it would happen again, but for some reason, guys are tough or something. I don't know. Or they think they're tough. Who knows? So it could be that the proportion is 0.53, and maybe we talk to 45 men, and then we talk to the women. We found that maybe the proportion is 0.34. Maybe we talk to 53 women. We calculate. So it's going to give us some numbers down here at the bottom. So again, if you read the message, it says the z-value is some number. The value of t is some number. The result is not significant at p less than 0.05. Guys, this is just an automated message. There's no guarantee that it's correct. It does not know what your alternative hypothesis is. It doesn't know what population 1 is versus population 2 in your hypothesis. So just be careful when using this. So here we can see a z value. We can take that out and write it down. So we can take, here z equals this 1.89. And then we'll have this p, which is 0.0587. So we have some information. We can then go to our flow chart. Since we're focusing on proportions, we want to use the second flow chart. So we have our null hypothesis. So I'll just write null. And we're going to have our alt. And again, from the research that I've done, men seem to experience more victimization than women. So in this case, it's going to be P sub female is going to be less than the proportion for not female. So here we're doing, we want to pay attention to this less than sign. So this is telling us that we're doing a lower tail test. So we go to our flow chart. We recognize that there's three options. We're doing this lower tail test. So again, our alternative hypothesis kind of looks like this example here. And then we look at our z value. So I guess there's like a line here. So here it's 1.89. It's a positive number. So we have two different options. So we're going to go to the one that's for when z is positive, which is the first one. So if the value in the phrase, the value of z is some number, it's positive, which it is, and we're going to divide the value in the phrase, the value of p is some number, by 2. And then we're going to subtract this new value from 1. So our true p-value, in this case, is going to be equal to 1 minus whatever was given to us, 0.0587 divided by 2. And this is going to come out to be kind of a large p-value. So we can do something like 1 minus, I think this let me do this, 0.0587 divided by 2. Okay, so we get 0.9706. So we have a large p-value, definitely larger than 0.05. So we're going to fail to reject the null hypothesis. So again, I just made up some data. It's like, don't actually assume this is how the world is. So, but under this fictitious example, we don't have enough evidence to reject this claim. It's possible that that doubting scientist is correct. And in this example, the proportion of females who've been the victims of crime in the past, no different when we look at, say, the proportion of males who've been the victim of crime in the past. So they're the same. Okay, what questions do you have for me? Okay, so I think we're good for today, so we'll end the lecture at this point. If you have any questions, feel free to just come on up, but if not, we're all good to go. The what?
Do you ever have the test on me?
You know, I might. I think I do. Yeah, take a look at it real quick. And I'll just kind of let that be seen.